Hi everyone. This is going to be a tutorial. I don't know how long it's going to go. We're just going to go through it. I'm basically just going to go through in the study guide. There should be a whole lot of questions, etc. It basically takes you through this R tutorial. So we're pretty much just going to work through each of the exercises and things in this, and I'll try to point out some extra stuff along the way. Okay, so if you haven't already downloaded it, the R website, so everything's free. One of the points of R is that it's a freely available resource, and it's quite a powerful resource. There's some other things that are similar to R, so MATLAB, you might have heard of, is essentially does everything that R can, and with MATLAB there's some nice packages for it, and it gives it, you can get graphic user interfaces that make everything look really good, but it costs so much money. So R is, I mean as students and everything, we get access to it, but in general, a lot of industry and a lot of companies, so industry companies and people in general, researchers as well, starting to use R more and more just because it's freely available, and so anything that you do in research can be replicated, and you can supply the R code, etc. for that. So in this website, basically, if you just go to download, it should download everything for you. Now, we're going to be just using this command prompt most of the time. There's things like RStudio, so we'll probably use RStudio when we're doing our tutorials at uni. It's got this command prompt, and it's got a couple of other windows as well that help you keep track of variables and everything. So when they're useful, we'll use them, but essentially everything that we do, we can do within the command prompt. So we'll try to keep track of that. Okay, so this is R. Basically, it has this little arrow here, and this is where we enter in our commands. And it basically has a, you enter a command, press enter, and it does it. You tell it to do things, and it does them for you. So calculations and things like that. So just basic calculations like 3 times 4, it can do for us. It can do subtraction, so 3 minus 4 can do. So you just press enter, and things come up. It can do more complicated things as well, so 56 divided by 3, you can get this kind of answer, and squares and things as well, so 3 to the power of 5, all of this kind of thing it can do. So it's the basic way it works. Just chuck thing in. Another important thing that it's able to do is you're able to assign things to variables. So you can use something like A1 equals 2. So you're allowed to use full stops or decimal points, etc. And it's able to do that. It doesn't like you to start with numbers though. So if I try to do like 2A equals 3, it doesn't work. But any letters are fine. You can also do whole words. And then, extra indices, etc. So 45, sorry, not 45, A 5.1, 6, etc. Now, once we assign these, it basically, at the moment, is just storing those as numbers. So I can recall them. So if I ask what A is, it told me that A is 3. If I ask what animal is, it'll tell me that animal is 4. But then we can also combine those together with operations. So I can do A times animal like this, and it calculates this for me. So this would be useful for us later on. So assignment of variables can be quite useful. It's reasonably intuitive. A lot of the time, if you can't do something, it'll tell you that you can't do something. So if we're starting slowly, we'll sort of build up the repertoire. So for instance, A-1 isn't able to be assigned. So for instance, if I tried to do A-1, then it just did it as a minus. So because a dash is essentially a minus, I can't assign A-1 because it doesn't like it. Okay. So basically, usually you use full stops or things like that. So I often find things like that, X equals 2, the y equals 3, the x times the y, things like this. So I usually work in that kind of manner. So all of these and everything works. So the x to the power as well of the y works as well. So we can do things like this and combine it with numbers, etc. So for the moment, when we're doing that assignment, and so the assignment is just less than and then an arrow and a dash, so it basically just becomes an arrow, and so it's just saying make the x equal to 2, or 2, we replace the x, or we define the x as being equal to 2. Do this. Now, what we're often really interested in is being able to assign vectors or use vectors. So vectors in R are basically done with a C tab. So I can make a vector for 5, 6, 9. So this is a 4-point vector. And so I write it with this C button. So C basically stands for column vector, as far as I know. And so we can have vectors like this. So we can do vectors powers as well. So 5, 6, 9. So if I combine this with, say, a squared function, it just squares each of those values. So everything gets squared. I can multiply everything. And so now what I'm going to do, if I press the up arrow, that just gives me my previous line. So I can keep on going up and it'll tell me all of the things I did. So if I just press my up, and instead of to the power of 2, I want to do multiplied by 2. So here, whenever you do a vector times a number, or a number times a vector, we can do it the other way around. So if I do 2 times this, then it just takes each of the elements that are in that vector and multiplies them or applies the operation. So all of those basic operations, including division, so here, multiple things, it's able to do and act on the vector. So often what we'll do is we assign a whole, a vector to a variable. So I can say the x is equal to this vector, 2, 6, 3, 9, or something like that. And so now when I have the x, I have it here. So this is my vector, the x, and now I can do like the x times the y. And remember, y was just a value. So if I want to remember what y was just 3. So this has just done everything in x multiplied by 3. So it's applied that operation. So already this can give us some really useful things that even in a program like Excel can become difficult. So if I want to do, for instance, a few other operations, I'll just make sure that I'm going in order. If I want to multiply everything by 3 and find out what the answer is, in Excel I'd kind of have to enter in each of the squares, and then I'd have to have an operation for each square doing that 3 times everything. So this at the moment is really useful. Now, other ways to create vectors, so we can do it as we've done it. So say an x vector, and it's equal to all of these points. Okay, so we can do things like that, but we can also create sequential vectors. So if I do instead, say the x equals 4 to 9, something like this, what it creates, so I'm using a colon, it creates 4, 5, 6, 7, 8, 9. So if I can do it 1 to 100, and now it's created. This is a long vector. It represents it in rows, but it's not actually in rows. It's just a single length vector, where each of the elements are like this. And then another way that we can create vectors is with the array function. So usually we do this as, for starting off, we create like an empty array. So I can say my array is, so I do the assignment So array is a function. The first argument tells you what to pre-populate the values with. So I'm going to pre-populate them with 0. And then my next value tells you how long it is. So I get 6 zeros here. I could just as easily create an array of 2, like this. So now it's a vector of 2's, and I can even create an array that repeats a different sequence. So my array, in this case, what if I do C1, 2? Okay, so I've entered in as my value instead of a number, I've entered in a vector, and I'm going to make it 30 long. And so now it just fills everything with that sequence. So it goes 512, 512, 512. So it creates an array or a vector essentially like that. So we can do combinations of all of these things in order to define different vectors. Okay. Now, once we have multiple vectors, and particularly when we have vectors of the same length, we can start doing operations between two vectors. Okay, so for example, let's say just do a simple vector. So A is C 1, 5, 6, 8, and B is another vector. So make it. Okay, so they're just two 4 lengths vectors of length 4. And so now what I'm able to do with these, I can now add them. And so in this case, it adds all of the components component-wise. Now, this is the usual way that vectors are added. So if you have studied things like linear algebra or anything like that before, it will seem okay. If I do multiplication of vectors, it multiplies the arguments together. So my vectors were 1, 3, 5, 4, 6, 7, 7, 90. And so now when I do A times B, I've got 1 times 3 equals 3, 5 times 4 is 20, 6 times 7, 42, 7 times 90, 630. So it does it component-wise. Now, in linear algebra or in vector arithmetic, there is no multiplication like this as such. So we have two things called the dot product and the cross product, and neither of them work like this. So this is in particular, I mean, there are some types of multiplication that are defined like this, but in general this is kind of a computer specific thing. So that multiplication here, it means multiply each of the values one by one. Now if I try to do say vector multiplied by different length, in this case, so it does so remember A was 1, 5, 6, 7, so it's done 1 times 1 equals 1, 2 times 5 equals 10, and then it's repeated this vector, so 1 times 6 equals 6, 2 times 7 equals 14. Now this is generally not how we want to do things, so it just does that so that the operation continues to be defined. But usually when we're planning to multiply or do things like this, we just want the vectors of the same length. But otherwise it'll just keep on filling them out. If we do something like this, it doesn't like it as much if it still gives us a response, so it kept on filling it out. So it just, instead of doing 1, 2, 8, it just repeated the 1 here. So it made it 1, 2, 8, 1. But it gives us a warning because it was a vector that didn't fit perfectly into the number of vectors there like that. So this is pretty good. Other operations work well as well. So A to the power of B does, maybe just remember what A and B are. So A to the power of B did 1 to the power of 3, which is just 1. It's given it to us in a funny kind of form because often it'll try to make all of the numbers given in the same representation. And so because it's needed to use some scientific notation here, it's then given all of us all of the numbers like this. So because 7 to the power of 90 is actually this astronomically large number, so this means 1.14 times 10 to the power of 76, so it's close to 1 with 76 zeros on it. So because it's done that, it's represented all of this in scientific notation to a particular precision, but basically these numbers are 1 to the power of 3, 5 to the power of 4, which is 625, 6 to the power of 7, which is around almost 3 with 5 zeros on the end, so 300,000-ish or 280,000, and then this large number here. So that's not, we don't usually have to interpret numbers like that, but okay, so there's some things that we can do so far. Now, there are some pre-programmed functions that work in R that are useful for us. So remember the average, we can just use this mean, it's already a function. Now the way to know whether a function kind of already exists in R, one way is if you write mean, you write an open bracket, it gives us this closed bracket automatically, so that's trying to help us out, but then it'll come up down here, so I don't know whether you can see it that well, but it comes up with usually the parameters of the function or the way the function goes in. So we can do mean of a vector like this, and it'll just calculate the standard average for us. So that's pretty good. We can do also mean of any of the things that we've done, so the mean of the A, 12.75, the mean of the B, etc. If we want to know what the mean does, we can just type it in without brackets and it'll give us what was kind of about to come up there, which doesn't always help us too much. We can write mean question, not mean question mark, sorry. Yeah. Okay, sorry. Took me a little while to remember what was going on there. So if you write question mark then mean, it'll automatically load up a help file and then it tells us everything that goes on in here and all of the details of that function. So it does that on a Mac. Otherwise, pretty much if you get stuck with something or you don't know how to use something, if you just go and do a web search, so just go mean in R, usually it'll come up with either something in this tutor or CRAN or Stack Exchange or something like this, and it'll tell us a bit about it. There's so much information online in R. I've never come across something that wasn't already implemented by someone. So, or at least the steps to implement it weren't there. So there's a lot of information, etc. online. Now, some other functions that work really well. So the median, for instance, so we can have the median of our set, so it does it automatically for us. We can do the median of multiple things as well. So, sorry, I typed it in wrong. So sorry. Okay, so if I do this, it's a bit confusing because the means are the same. But if I combine these two together, it doesn't particularly like it if I just do it like this. But this basically just combines the vectors A and B together and then finds the median of all of them together. So I could do, median of, so all the values in A, all the values in B, and then even add a few more. Okay, and then so now it tells me that the median of all the numbers in A, all the numbers in B, and this other thing is equal to 5. So the median is one function. Other functions that are useful for us are the sum. So sum of all the elements in A is 19. So if we look at A here, so 1 plus 5 plus 6 plus 7 is 19. We can do the sum of all the elements in B. We can do the sum of all the elements in A and B. And this, in this case, so different to the median, whether we combine them together into a vector using C or have them like this, it's able to calculate the values there. So this is really useful for us. So now already you know how to, we can do something like multiplying values together or doing a weighted average, etc. So what we'll do actually in a couple of weeks, so won't look at that quite yet. But other important functions that we use, so just refresh here. So product, this is going to be very useful for the geometric mean. So if you do product, prod of A, it does everything in A multiplied together. So product of all the numbers in a vector, you can do product of B, be a little bit larger. We can also do length, is sometimes useful. So length tells us how long A is. So if you remember my array, it was the array that I created that was like this. So it tells me how long it is. So again, this is really useful for calculating means and averages because it tells us how many values there are. So we could actually do our own version of the average. We can do the sum of all the elements in A divided by the length of all the elements in A, and that would give us the same as just calculating the mean. So we can essentially create our own version of the mean if we want. Other important things, the minimum. So it tells us the minimum in a vector. Okay, so the minimum value. Also the maximum. Tells us the maximum value in all of those numbers, so it's also pretty useful for us. The other thing that we might want to do sometimes is look at multiplying, so two vectors, and then calculating the sum. So if I look at A and B again, okay, so this is my A and this is my B. Now if I do A times B, I get this, and then I can do sum of A times B, so which adds all of these together. So when I do sum of A times B, it first multiplies all of the corresponding components and then adds them together like this. So this is really useful for us as well later on because it can create a lot of shortcuts. Okay, now the next thing, and I think could be one of the last things that we do. Yeah. So the last thing that we learn in this week, and I hope to follow everything you've either been looking through the extra notes on the tutorial, and you can pause this obviously at any time. The other thing that's really useful in R and that we're going to be learning a lot of is actually creating our own functions. So there are some predefined ones in there, mean and median, etc. There's nothing for the geometric mean though. Whoops. Accidentally did a search. That's alright. Okay. So about that. So you'll notice, like there are some functions that come in there as standard, but obviously not everything. So for instance, our goals this week are to create functions that calculate the geometric mean and functions that calculate the harmonic mean. So, in order to create functions, basically it has a few different steps, and sometimes it's easier if we create a new file that we kind of store our steps in. So, if I create a new file here, okay, so what I can then do is I kind of store things that I'm going to have here, which I then copy and paste in. So functions, basically, again, we can use assignments, so we can assign numbers, but we can also assign functions. So let's just do a function like this. So it starts with the assignment as well. And then we have this notation, so function of x, bracket, like this. Okay, so now this is a special R operation that it does, so this function x, this tells us what inputs it can take. So x can be a single value, it can also be a vector, but we have to make sure that the operations that we're going to put in here are going to be appropriate to whatever that kind of thing is. So let's just do something reasonably similar. Now I'm writing these on separate lines because it's easier to keep track of, but we can write it just on one line, so I could do it. It's fine to write it all like this, and for some things it'll be easier to do it that way. So I basically want to define a sequence of operations, or just an operation, so I could just do something like cubed. Now we've got curly brackets either side here, which is really important. Okay, so I take this, I can copy it and paste it here and then just enter it in, or I could have just typed it all out. That's fine. And now when I enter in a my function and I put in a value, it'll give me an answer. So that now I've created a custom function that just takes the number and squares it. It also works for, since in the operation that I defined here, that operation, since that works on vectors, putting in a vector here as well is fine, and it just provides the function in that way. So I can do any kinds of things here. I can then add a number, then take everything. So if I write, all of my steps in here, or maybe I'll divide by 3 or something like that. So this function, and now when I take 4, so what that's done is it's taken 4, cubed it, added 1, then divided that number by 3. It gives me an answer like that. And so, we're going to do a lot of complicated things, but basically this allows us to create geometric means and harmonic means because we know how to do all of the components of these now. Okay, so why don't we just go straight to it? Okay, so I'm going to call it gmean. So it's going to be a function like this. Now, remember how the geometric mean works. I might write it different functions here. So remember, it's all of the values multiplied together. So we can already do that with the product function. So product of our input. So it's going to take, now I could do it as separate inputs. So I'll go through that in a little bit. But for the moment, I'm just going to assume that the x that is input into my function is going to be a vector. So I take the product of that, remember, and then I raise it to the power of 1 over, and it's n, and so to calculate n we do it like this, so 1 over length of x. Okay, now I have to be careful with all of the brackets and everything here. Basically this is going to have product of x. If you're scared about the order that it's going to operate things here, we could put brackets around that prod there, but it's okay because it'll create it first. To the power of 1 on length x, that needs to be in brackets like that. And so this is going to create my function. So I take that. So notice here I've got enters between there. That's okay. It can handle enters. So it does it in R as just these plus things. I also could have just entered it in. If I enter it in line by line and it doesn't think I'm finished. Okay, so I go like this. Enter. So when it comes up with a plus here, it means that you haven't closed off a bracket or something like that. So I can just keep on doing this here. Okay, so I've now got my geometric mean in there. So now I can take, now remember it has to be a vector, like this, and so that's given me the geometric mean of these numbers. I can do it of even more. I can add in my A vector as well, and so it'll give me the geometric mean here. So that's useful. We've created a function, and we can go around and use it. Now we could also create different versions. So the geometric mean, this is for any length, but I could create a 2-variate version. So now I'm saying that the function requires 2 inputs, like this. And what it does is it does x times y, so it's the product of those numbers, and then takes the square root. So actually I forgot to mention square root. It's another one that's already pre-programmed into the function. So you can just take square root of xy, so that's the 2-variate g-mean. Okay. And so now, when I take g-mean of 2, I can take any 2 numbers, and it'll calculate the geometric mean that way. So I can do it with that one, or I can do it with 3, 5. So the difference is here, I just had to enter the 2 numbers in, but then here it needs to be a vector. Now, if I entered in 2 vectors into this one, what it would do is it would multiply those numbers and then take the square root, and that'll actually give me a vector answer. So I need to be careful. So if I have, say, 2 vectors here of length 3, so this particular one, it's not so good, it doesn't give us the geometric mean. So it's defined for 2 inputs when the inputs are numbers. This one's defined for any length, but we have to input a vector. So that's maybe for some of you a reasonably new concept and something that we need to get used to. And also, like, it's, you know, a common easy mistake to make. Like, you're typing away, you're saying, okay, calculate this, and then you forgot to put the C in, and so nothing works. So that, you know, that's frustrating when that happens, but it does happen sometimes. Okay. So, as I said before, we can also create functions like the mean in this way. We can do my mean. So, not that it's not that we need it, because the mean's already in there, but so basically this would just be the sum of all my numbers, so sum of x, and then divide by the length of x. So I could have that as my function. So put it in there, and then I mean of C of... Oh! What did I do wrong? So sum of x divided... Oh, I didn't spell length right. So it let me make it as a function, but then the function doesn't do anything. Okay, so it's able to output that here. Okay, now one note about the functions is it always gives the output as what is here. So if, you know, I could create a function that has on this next line just x. So all this is going to do, okay, it's gonna calculate the mean here, but then what it reports is just on this last line before I close the brackets. So this essentially is a function that does nothing. So now if I have, yeah, I'll just take the same thing that I put in before. So I put in that, and even though it calculates the mean for me, it doesn't tell me what that calculation is. So there are ways for us to see every step of calculation if we want every step of calculation. So that's with usually sometimes a print command, or to store the different variables. But yeah, basically you need to have it as that last line. Some other things, we can do assignment within a function. So for instance, for creating something like the mean, I could say n equals length of x here. So I take x, I find out what its length is, I then store another variable which gives me the sum of x, and then I report s on n. So this as well will work just fine. So it's got 3 lines of computation there, but it still works. So, you know, there's many different ways to program exactly the same function, and different people have different styles, and so if you do know anything about coding, you probably know that reading someone else's coding is always really a horrible thing, because everyone does things differently. but you need to work in a way that you can always check over and make sure everything you're doing is fine. So with these functions, and when you have it in a multi-line way, it's always this last line of input that it'll report. So it'll report the value of that last line of input. Okay, are there extra things that we need to do? And so if one of the examples that I've got here is if we do something like this, since that last line is an assignment, so it's assigning A, it actually is not going to output anything into the function. So have to be careful of that. Now the other one, we do have harmonic mean here. I can actually just copy and paste. This should work, as long as it doesn't do anything weird. Yep. So to create this function, so the harmonic mean, again, it's a function of x. And what it does is it multiplies the length of x. So remember, that's our n value. And then over the sum of the 1 on x. So it creates 1 on x first. It then sums all of those up and creates it that way. So remember, harmonic mean of, now I have to have it as vectors again. So 3, 4, I think we had 3 and 5 hours. This kind of thing was 3.75. So that's working as well. Okay, so I hope you're all pretty comfortable with all of those things. We're going to learn how to do more complicated things. Within a function, you can have so much going on. Like, it's really good. Like, so, if you think of setting up a calculation table in Excel, if you've ever had to do that and you have to do columns, separately calculate all of these things, you can set up, especially with some of the sophisticated functions that we'll get, really easily. Even something like the geometric mean, in Excel, I'd have to individually, I could do a product of a whole row, but something like the harmonic mean, it doesn't have that kind of function, so I would actually need to go through, create cells, and then work out for each cell what 1 over that cell is, or program them in individually. So whereas with something like this, this is one way of writing it anyway, it's like one line does it for any number of variables. So, whether I've got 100 inputs or 2 inputs, I'm able to do this kind of thing. So, it's really powerful, really useful, and so, for any kind of analysis and things like that, you can imagine why it's good to know how to do it. But it does require, having a good sort of understanding of logic, especially some of the things that we'll get into. Keeping track of things, keeping track of brackets, and keeping track of logical operations can sometimes be difficult and daunting. Okay, so there's some extra questions that are in here that I would encourage you to go through. Some of them are just calculating values. So so here, calculating these. So there's a typo there. But basically, if you either program in the functions yourself or just copy and paste what I've got there, you can evaluate these and kind of have a look at the difference, have a look at the difference in results. So because of geometric means and harmonic means tending towards low inputs, etc. There's just a little activity here to create a 2-variate version of the arithmetic mean, so similar to what I did with the geometric mean there. This is an investigation type question, so if you can type in this function, so maybe try it as a 2-variate version of the function, and then try to show that it's not a monotone function is the basic idea. So you should be able to see here there's bits where we're increasing one of the variables and the function's actually going down. So even though it satisfies a lot of properties, it's not actually technically an aggregation function because it doesn't satisfy this. So R in this kind of analysis can help us find just a numerical example that disproves something like that. Then questions here similar to what's on the quiz. And then this question 6 is looking at outliers, and question 7 looking at outliers. So some simple questions there to help you apply the things that you've learned in the R tutorial. I hope that was useful and easy. With R, so you can keep notes and everything on here. For me, like, I do remember a lot of things, but basically, you know, as long as you've got internet capability when you're programming, I usually rely on, you know, looking up an old file that I saved that I remember how to do something, or just doing a new search and saying, you know, if you forget something, oh, how did I do it? I do that. Because, I mean, there's going to be thousands of different things that you could potentially end up wanting to do, and, you know, it's not expected that you would remember them all by heart. So ones that you use often you would remember by heart, but other ones, yeah, I mean, that would be crazy. So, you know, even getting used to that kind of workflow can be really handy as well. Now, basically, for, you know, you could use these to help with your quizzes, but all of the quizzes, they also are fine just to use Excel or any other kind of calculator, usually in calculating values. This would make it easier if you have it like in a separate window or something to do. But mainly the time that we'll use R is for the assignment. So the assignment will require you to do an investigation with a large data set that you know, will be much easier to deal with in R than doing everything by yourself. Okay, it's good. So I'm also going to put up some extra lectures. I hope you're having a lovely week and nice weekend and all that kind of stuff, and I'll see you later. Bye.